Right. Good day, everyone. Thanks for joining us. This is our NetBox community call for November. We're recording on November 21st. Let's get this started. So before we jump into our topics for the month, I'd like to invite any of our participants to have your cameras on. We do like to make this more of an interactive community event. So once we get into the presentations, I know we'll be looking for some questions if anybody wants to come on and ask, have those in chat. But really, this event is for the NetBox user community. So anytime that we can have you participate, we really love hearing your voices and seeing your faces. So this month, we'll go into our community news like we typically do. We do have two presentations this month, so we'll jump into those. And then towards the ends, we'll get into our open conversation. So this month, oh, you know what? I need to refresh because I don't have the current slide deck in front of me. There we go. October has been a little bit of conference season. We were at 3 conferences and actually hosted one of our own. The one that we hosted was NetDevOps Days in New York as a automation specific events talking about network automation. There was a lot of NetBox conversation in there, obviously. But yeah, we had that going on. We were also at NINOG, and as it turned out, we shared space with NINOG at this event. So we had some presence there at NINOG. Earlier in that same week was ONUG. We were there. I know we had a lot of booth participation. We had a lot of people come up to the booth, say hi, and asking questions. And then we were also at the Network Automation Forum, I think it was a week or two later in Denver, which we had, again, we had a booth there, a lot of great conversations, a lot of people walking up to the booth, some just to say hi, some to talk a little bit more in depth about NetBox. But either way, October was a busy month out there in conference land. Next, we're going to jump in and talk a little bit about the upcoming releases for NetBox, which I think, Jeremy, we've got a slide for that. And if you don't mind, take it away.
Yeah, of course. Yeah, just some real quick notes as reminders. NetBox version 3.7 as part of our 4-month release cadence will be out by the end of December this year. 4.0 will hopefully follow it in April of next year. But we have our first beta due out next week, and I am working frantically to make sure that happens. We've got a lot of cool stuff coming up in 3.7. If you haven't already, go ahead and check out the milestone issues for 3.7 on GitHub. You'll see a lot of stuff is there. We're pretty much just wrapping it up right now. I'm confident that we'll have a good release to show sometime early to mid next week. Some highlights include event rules, so being able to automatically take actions in NetBox, such as executing a custom script in response to events that happen according to some administratively defined rule. We're implementing modeling support now for VPN tunnels and virtual machine disks. Also, we've got some improvements to the global search. So now we'll be able to show additional attributes, I'll kind of attach them to search results now for different objects. So that'll be pretty cool. And we have started work on translations. So I don't think we'll see a ton for the beta itself. We'll probably use the beta period to help work on and contribute to those translations. I know we've got Renato is working on Portuguese. We've had a few people volunteer for other languages as well. And we're using a tool called TransFX, which is the same tool that the Django project uses actually to manage all their translation contributions, which is nice because it has kind of a separate UI. It keeps it completely isolated from like the Git workflow and everything. It's a lot more convenient for translators. So we're still working on some integrations and getting that set up. And yeah, hopefully when we actually go to release 3.7, we'll have support for at least one non-English language. So I'm pretty excited about that.
That's awesome. Thanks. Do you mind if I talk about the feature that I'm most excited about in 3.7?
Is that tunnels?
It is VPN tunnels. When I worked in healthcare, I think I had something along the lines of 150 tunnels that we had to maintain, and they were, along with all the rest of the documentation in spreadsheets. So that we're getting a feature in there specifically for tunnels to help map and track those. I'm really excited for engineers out there who have to deal with a lot of tunnels to be able to track that inside a NetBox. So super
Yeah,
excited for
absolutely.
that one.
Yeah, and for what it's worth, we're intending to model both point-to-point and multi-point tunnels. So think about like Cisco DMVPN, that kind of thing.
Tout ce qu'il y avait en arrière. En arrière de ta tête de lit, puis en arrière de ton lit.
Hi, Jonathan.
Sorry,
Thank
I
you.
don't think that was a thought that was a question, but I hope not, because I don't think I understood the language. So modeling different tunnel topologies as well as the crypto profiles, which has just been a series of rabbit holes to go down. I thought I knew IPsec before, but now I know it even better. Which will happen when you go to model things like that. But I'll reiterate what I always do, and please help us with the beta. Things like VPN tunnels especially will be very easy to help evaluate, because we'll have the public beta demo instance going again, like we as per tradition, and we'll get that going. And please, if if tunnels are part of what you do, by all means, check it out. Try modeling, building out your own stuff in the demo instance. Let us know what works, what doesn't.
Mm-hmm.
Tunnels are one of those things that they're fairly well defined, but they can also be kind of nebulous in some respects. So we're trying to capture as many use cases as we can. Can't promise that we can support every single use case, of course, but we'll make an effort. So when that beta does come out, hopefully sometime next week, let it go ahead and check it out. Let us know what you think. Appreciate it.
Awesome. Thank you very much, Jeremy. Before we go forward, because we're going to be getting into the presentations next, if you do want to take a look at the milestones that are out there for either 3.7 or 4.0, when you go to the issues page within the GitHub repository, you'll find a little subheading there that lists milestones, and you'll be able to see the 3.7 and the 4.0 milestones that are out there, the issues that they tie back to. So if you do want to dive a little bit deeper and help us out when those betas do come out, that'd be a great place to start, in addition to the public demo. All right, so we're going to go ahead and get into our presentations. We have two presentations this month. We have Dave Kempe. We also have Jonathan Senecal, and not pictured here is also Francois Menard, who will be presenting with Jonathan. But Dave, since it's the earliest for you, I think it's around 3 o'clock your time, we'll give you the honors of kicking off and starting.
Thanks, Jordan. How you going?
Good.
So I had a presentation and presented this at OSMC recently. This is we're going to talk about a plugin for NetBox that we call Path. One of the things you always struggle to do when you're coming up with new software projects is giving it a name. So I welcome feedback on that. NetBox Path is designed to extend the idea of NetBox to allow us to model the logical relationships between devices or virtual machines interfaces, and then provide a diagram of how that relationship works, and then on top of that provide an API to allow us to model the impact of either of those things going down in the monitoring or however else we want to be able to do that. So I'll show you the current state of the code and where we're at. Is that all working nicely?
Looks good.
Great. All right, so NetBox Path is pure plugin. We've got it working on 3.6.3 at this point. The code I think has only really been tested on 3.6 and up. It's available on GitHub. You can list out paths. Paths have names, and paths can be sort of arbitrary complexity. If I pick one of the paths I've prepared here, you can see that a path allows us to sort of save it, fit it to the screen, lock and unlock it. We're using a JavaScript library here called Cytoscape to allow us to model graphs. So a graph is a mathematical sort of idea where we've got edges and nodes and edges can have properties. And in our case, we've allowed people to have an edge to have arbitrary groups of attributes that you can display, and nodes can also have arbitrary groups of attributes that you can display, and then importantly, they can be attached to the API, and I'll get onto that in a minute. Cytoscape is a real graph library in the sense that you can do graph maths on it and figure out the direction of the edges, calculate where the start of a path is, because there's nothing pointing at this particular node, and then I can map things out. So I can add a device to this path as an example, or a VM interface, and we've picked these types of NetBox objects to be able to add to paths, but it would be easy enough to add more, and it really kind of comes down to your imagination as to how you think from a sort of organizational point of view, your devices or interfaces or VMs go together. And this was really driven out of a number of our TV station customers where we support NetBox for them. They use a lot of multicast video, and that multicast flows through, from an encoder to a switch, through a router, through a arbitrary provider perhaps, and then back into another switch, router, decoder at the other end. It's very much a particular set of network interfaces, particular multicast addresses, or particular devices that are involved. And a lot of these solutions have redundant paths, A paths and B paths, hence the name path. It'll prompt you to save your changes if you've made changes. And paths can get arbitrarily sort of complicated. So here I've attempted to model how a Zimbra cluster would work. In this case, if I unlock this, we can see, I'll just sort of walk through this here. We've got a circuit, which is a provider, and I can, view that in NetBox, loaded in NetBox, and then see back on the, why is that not working? Back on the device, what paths that device is on. And then a device here, if I pick another device, I've loaded the NetBox demo data here, the number of paths that this device is on. So this is helpful immediately for people that want to mess around with this particular router. They can come here and go, well, this router is carrying, the NHL live to Japan, and Woody's one of my guys, and NBA to Frankfurt. And so, if I reboot this router or unplug this interface or down this VLAN, then that path will be impacted. So if I go back to my Zimbra cluster, on top of that, I've added to this diagram at the edges, I've added properties up to them. So failover or SMTP or HTTP and LDAP. You can see here how that allows us to sort of have arbitrary complexity. I mean, there's an argument to be made here that this path contains multiple paths, so the SMTP in yellow is really one path, so to speak. HTTP might be another, and that's fine. People think about the way that their stuff works over the top of objects or NetBox objects kind of in lots of different ways. We want to be able to build a tool that lets people sort of capture that arbitrary relationships. The real question, though, is, I guess, why? The answer to that is because we want to be able to use the API to query it. So in particular, a path can have contacts, and those contacts ideally are contacted when something goes wrong with this path. And because we've built out extensive integration with our monitoring system using iChinga, and we automatically pull NetBox objects into iChinga and then monitor those as part of when something fails in iChinga, we can use the notification mechanism in iChinga to call back to the API for NetBox path and notify the owners of paths that their path has been affected. So in this case, for example, we might, if this proxy goes down, we might notify this owner that the impact here is that, LDAP is going to be unreachable from the internet, or however we might want to do it, as arbitrarily as we like. So the path API has, typical sort of NetBox data, and you can see all the nodes and then parse those as required. And then on top of that, we've got a separate API for actual impact assessment, where we can see contacts, and then we can see a direction as well here in terms of upstream and downstream. And we've written a Python notification script that can parse the output of this JSON, figure out which ones are upstream, which ones are downstream, because you can pass in a particular device or a virtual machine or however you want it to go, and say, right, okay, this device has got a problem. How does it look in the path compared to all the other devices? Is other things upstream and downstream of them? Some of those things may be relevant to be notified. Some of them may be relevant to take an action against. Some of them may be relevant to sort of, provide some sort of failover action, or however else you want that to work. So we've tried to come up with a sort of arbitrary way of describing these things, and then, let people be able to do that for themselves. So that's pretty much the demo. I had some slides. I had some slides prepared for another talk, but I think this is best served by a demo and then hearing any questions. And does anyone have any questions around that?
Yeah, so we have one question out of chat from Eric Brown asking if can a path be added as a component of another path, essentially creating hierarchical paths?
That's a great question, Eric, and a cause of some debate in our office as we develop this. The answer to that question is yes. We decided to not put it in for this version. Now the issue, so it is a real NetBox object, and we could add it here, and then you could have, so instead in this instance, this would be the SMTP path, and that would be a separate thing, or however you want that to work. So yes, they can be. However, the only problem is that your path needs to have a beginning and an end to be able to model that impact. Otherwise, you're going to end up with a loop. So there's a few loop prevention things, and there's a couple of sort of logical graph theory problems with having paths inside paths. So we just want to be careful about how we model that out. But we welcome feedback on the repo, and happy to have a crack at it and model things out and see how you like. At the moment, what I've sort of settled on was, well, given that the edges can be classified, and then in the API we can group and classify edges together based on whatever properties we want them to have, and any other metadata, then that should be the idea of paths within paths anyway. But we're happy to have paths as object as well. There's some debate around that. Yeah, that's where it's at.
Nice. Thank you, Eric. Do we have any other questions? Let's see, got one more coming in. How do you factor in redundancy concepts as they would be required by a telco?
I'm not familiar with exactly what telcos require from that point of view, but as far as TV stations work, they have redundancy involved here. So, I mean, redundancy in NetBox is modeled in lots of different ways. FHRP groups or virtual chassis clusters. There's a couple of I think, frankly, sort of different attempts at sort of trying to figure that out, and maybe one of you guys can correct me. But that this is actually sort of was driven out of that idea that for video in particular, when we're trying to deliver video, between around the world, it might have an A path, a B path, and a C path. Or for one of our customers, they even had like 6 data centers, and 3 of them had to be up out of the 6 to make that work. So the point here is to actually attempt to capture that, draw those real devices with real links, and then put them all into the one path, and then add enough metadata to the edges and the nodes to be able to then group those things together. So to say, this is part of the A path, this is part of the B path. But I'm not sure exactly what a requirement from a telco would be over that as redundancy as far as that's concerned. I'm not sure if that helps, unfortunately.
We'll see if he expands on that. He said he's good. Thank you.
Okay.
I have a couple questions for you, if you don't mind.
Sure.
So when you're drawing these, this is all manual, right? There's no calculation involved in here. There's no help me find the best path. As the engineer, you've already decided, okay, here's the path, here's my failover, my redundancy. Is that correct?
That's right. Yeah, this is sort of targeted at, I think, less there's a category of engineers that are more sort of system owners. They do the architecture, they sort of know how the system actually works. They're less concerned about which rack unit a switch is in and more concerned about sort of the overall service delivery aspect. So system owners would then be the contacts on those paths, and so they already have a high level design, and this is an attempt to express that high level design in an authoritative way in the source of truth.
Okay. So can you, I know the API is used for pulling data. Can these paths be created through the API as well?
Yes, and it would be complicated to do. We have done that. There's nothing to stop that from happening. The issue is that you'd have to sort of figure out how the JSON worked and then post it correctly. And there's a lot
Right.
of complicated bits and pieces that go with graph theory to sort of make that happen. It might be that you can, for example, just plonk all the objects down onto a graph and then
Right.
join them together yourself or anything like that. So it's not something that we could have sort of like anticipated people doing a lot.
Mhm.
However, we did add a sort of screenshot button here that will create a screenshot of a path, and we actually use that in the API to be able to capture the screenshot of the path when we're notifying people around impact, and be able to send that embedded in the body of a notification message that says, hey, we've got a notification that a device that's essential to your path is down. The path, whatever it might be, has lost redundancy or is affected. And then here's a screenshot of it in case you forgot what it looked like, because
Sure.
system owners may not be, sort of on the periphery of some of these things. They often, have jobs as architects and they're dealing with customers perhaps, or they might be pre-sales engineers, but they're not necessarily at the forefront of either monitoring or using NetBox. So they will sort of tend to, be secondary notification contacts or secondary people involved. So
Okay.
being able to sort of provide them with a reminder about exactly what it looks like
Okay.
is the way forward.
And the reason I asked those two questions, and I'll kind of tie them together here, is out in the community, been hearing some requests for help mapping circuits. And I struggled with the terminology initially, because I always heard circuit as internet circuits. Is it Comcast? Is it AT&T? Is it Virgin Mobile? Whoever it is. But for campus network operators, they have this concept of a circuit where it's a path similar to this, but it's through dark fiber, more or less, that they own from point to point. And we occasionally hear a request that it would be great to be able to say, hey, I need to get from building A to building Z, and I have these different fiber pass-throughs that I could potentially get to. How do I keep track of that? And this seems to start to go in that direction, where it may not, count how much, how many dark fiber pairs are available or anything like that, but you can still map out that path at a much higher level, at that conceptual level. So I really like where you're going with this.
Yeah, that's quite possible that would work. A lot of those things sort of exist in people's heads, and they're not necessarily, or in a diagram. And how does this actually work? And it's hard to discover exactly by looking at all the configuration of the various things what's actually there. So I think that would fit with that use case. We welcome people to try it. I mean, obviously, what we're getting into here is the way we use networks and the things that are in NetBox, and it's great to have a source of truth, but for many people and all these sort of system owners and managers and all those kind of people, this is their truth, which is that the actual deliverable. They want to be able to deliver Zimbra or video to Japan, not a BGP circuit or all those other kind of things. So
Yep.
that's our attempt here to sort of bridge the gap there between high level designs and the source of truth.
Well, I'd say this is a pretty good attempt. We've got one other question again from Eric. He'd like to know what you're using for the underlying storage.
Yeah, so it's just a Postgres. It's the same. It's stored in the database, the same database that NetBox uses. It's a typical way the plugin works. JSON is stored in there. There was some questions around how we do that. It can end up being a complicated structural sort of problem to be able to sort of have arbitrary JSON blobs and things. So we've attempted to just use the standard database and not have external storage. That was also discussed though. And it's something that we'd consider as part of that. We kicked around all sorts of different types of storage. Yeah, that's where that's up.
Awesome. All right. We have one other comment just out of chat. That's John and a coworker were discussing a need for this just the other day. So sounds like the timing is very appropriate on this. Dave, I want to thank you for waking up early and presenting. We'll go ahead and wrap up on this, and we'll start in with our next presenter. Just a reminder for the group, if there are any additional questions, we should have some time at the end, and we can open it up for questions there. But next, we'll go in with the presentation from Jonathan Senecal and Francois Menard. And I think, Jonathan, you're kicking us off.
Yes, I am. So, hi, everyone. So I've been approached by Francois Menard and his company, Polar Technologies, to develop a plugin for their actual product that they designed and are putting out in the world. And this plugin basically enables NetBox to interact with the outside world, to physically interact with cable tags that they designed, and many other tags. Actually, they do also another kind. So I'll let Francois show those later, but the first part will be more like a presentation about the plugin itself, and Francois will show how it works in real time. So let me start sharing. There you go. Let me know when you see this.
It's coming through.
All right. So it's a small demo instance running a local host. Nothing fancy there. Some demo data added there. So most of the time when you basically have to trace a thing, you just look through the device. You just go through that. You go look at the devices, and you pick up your server, your thing that you're trying to find, and you go and map it and look at the cables and stuff like that through the interfaces. And then you tell the guy remotely, hey, in whatever remote hands you have, please try to find this cable connected to, the second interface through the back. I think it's from the left. I'm not sure yet. Well, that solves this issue, really. So you basically have those cables that you mapped in NetBox because you're a good NetBox user and you mapped everything. And you now have a locate button. This locate buttons basically pulls the data from the plugin itself, and when you click on it, it basically calls an API and sends a request to locate tags. Those tags are designed to be just documented as simple objects, just like that. You give them a locality, some information about the RF tag. This is basically the address of the tag that the RF reader is going to use to reach out to that device. You define the reader. It's a NetBox device. It's using the primary IP address to reach that. And you can add it some metadata, potentially a tenant if you want, and you assign it to a thing. Could be a device, a cable, or a rack. In our specific case, 2 of those tags are currently assigned to cable number 1, and this tag is actually assigned to server 02. They're all using reader 1, which is a kind of virtual device I built inside a plugin just for the demo. It's actually calling an API I have at home. But Francois has the real thing. So it's very, very straightforward. You basically have all the other tags. If you have one that's actually connected to the same thing as another, you have the others. You can locate each one individually. And it's basically just a documentation thing. It's very simple, but it's very useful at the same time, because you could go from any related object that has a locate button or whatever, or locate tag, and you basically have it appearing there, and you just click on it to locate the thing that you're trying to find. If you, for instance, have a cable that spans many rooms, you can have as many tags as you want over on that cable and just have it light up over the distance. So very short, very quick. Francois, do you want to show it actually do something?
Sure thing.
So
So,
I'll stop sharing first.
yep. So thank you everyone for allowing us to present our heli tag concept, which are tags that are, I'm going to unblur my screen. So sorry for the mess in the back. So this one is an NFC tag, and you can read and write to it using your phone, but the read range will be very short, like a centimeter or two at most. And it's reusable, and it's not really good for monitoring cables in a rack. This is where, instead of using NFC, then you use a UHF tag, which has a read range that is much bigger. But if you look at this one, it has something special on it. It has an LED light. And so without batteries or wires, totally passively, you can do something like this, which is the demonstration of what I want to show you. So it's a computer rack, which has, it's a demo rack. Stop moving the camera, 1 second. And then I kind of was showing you the locate button, so I'll show you what happens on the locate button. But before I show you that, sorry, is you see the heli tag is, hopefully nobody's going to feel dizzy. It's actually attached to a cable, but in the rack, you'll find that there is a radio frequency antenna that is attached to an RFID reader. The RFID reader is pumping radio frequency energy into the RFID cable antenna, and this one emits energy and to the tags in the rack. So with this, when you hit the locate button, the tags will harvest energy. Sorry, the camera is tough on staying stable. Okay, and so I'm gonna pressing on this and going to my instance of NetBox, and I hit the locate button.
And Francois, I'm going to pause you for just a moment. For anybody in the audience watching, if you want to switch your view over to speaker view so that you can expand Francois's video here to see this in a little more detail, I suggest you do so you can get a clearer view. All right, go ahead.
Right, so if you've seen it, you've seen the tag go green, and if you can confirm that, that'd be awesome. Which means that any amongst a sea of cables in a rack, you can then easily confirm which one you're intending to manipulate, which is good for the typical method of procedure of transferring a cable from one switch to another switch in sequence, and make sure that the knock, which is guiding the guys in the field or ladies in the field to actually perform the change, is they're actually manipulating the same cable that the knock is intending people to manipulate. So if you push it a little further, you could say you've got your augmented reality goggles with a visual overlay of the physical reality as driven by the knock. And so we call this the digital twinning of cables. This lets you build a complete physical view of the network. And this is where NetBox will eventually tie into VR models of the infrastructure. And the beauty about this at the end of the day is once you have that RFID reader in the rack, you can do a lot more than just visual cable location, because RFID tags exist in various forms. Some will measure temperature, some will measure humidity, some will measure stress, vibrations, capture light, emit light, and so that RFID reader becomes basically a sensor enablement node, which will let NetBox evolve into basically a data lake of sensor data and down to environmental. So it bridges the gap between physical network infrastructure documentation and DCIM for infrastructure management. And this is where we're heading with this technology, and we hope to get feedback from the community.
And it doesn't all only pertains to cables. You also have device tags that you can attach to those, right?
Yeah. So the beauty about patch cables is you can follow them from the inventory to deployment to the grave, and you can start to do stuff like mean time between failure analysis and statistical data. So say you have a heli tag on a DAC cable, and the DAC cable gets retired out of a rack prematurely, you can find out where it was used, what temperature was it exposed to, and if you have the data lake that has captured the peak temperature that the cables was exposed to, you can do some correlation. You can also correlate the temperature with a heli tag that would be attached to a cable and measure the actual temperature of the cable itself, with the RFID chip measuring the temperature of the cable. We would do this not necessarily for DACs, but we would do this for electrical cables to find if they're being overdriven and they're over solicited. The other use cases that we have in mind is basically allowing very simple installation of tags on patch cables as you deploy them. But you know, patch cables have measured data on them, like insertion losses, return losses, and you lose that information as soon as you take the cables out of a bag. Well, then you can copy that information along with the circuit ID and a whole lot more information that you would never be able to write on a roll-on label that my aging eyes will not be able to read, but my phone picking up the data from the NFC chip on the tag will easily be able to. So if you don't mind with the reading range being centimeters, NFC is great and super cost effective. If you need monitoring and range where you can leave a reader in the rack, then you get to use UHF technology, which is called RAIN RFID technology. And this will do meters of reading range, including allowing chips to harvest the energy from the RF and power up the chip and return environmental data.
So Francois, for
Yeah,
this, for the plugin that Jonathan has written for this, yeah. And maybe I missed it. Maybe can we see how that works?
Okay, so I'll share my screen because I'm actually running the plugin on my end. So the here. Okay, so what we have here in NetBox is, say you take a device, say you have a patch panel, and on the patch panel there's front ports. On the front port there's a cable. You click on the cable, you click the locate button, and as I hit that, then you'll see that tag blink.
Oh yeah, there it is.
Right, so that's the magic. It's as simple as that, and it's physical feedback from the infrastructure stemming from the RFID reader in the rack. And
so then,
yeah.
Sorry, go ahead.
Well, but then you can imagine that you get 1,000 cables in a rack, and you have 1,000 RFIDs on each of those cables. In fact, you would have one on each end of the cable, and you'd be able to say and correlate an end of the cable to a patch panel position, and then especially move cables away, not necessarily from patch panels, but from one router to another router as you're doing a router upgrade, and
right.
Sequentially say move that cable now from this router port to this other router port.
So Jonathan, and maybe this is a question for you, or maybe this is for Francois, but in terms of the plugin, is there an exposed API as part of this, or is this purely UI interactions?
Okay, so the locate endpoint is an API. So you basically tell it, well, locate the thing that you want to locate. So it could be a device, could be, I'm sorry, I'm hearing myself. So you have endpoints to locate devices, cables, or racks, and you have endpoints on the RFID as well, just to locate it. So it's basically just if you know the tag, you just pass it the argument and it locates it. The way it's actually plumbed is that Francois is developing an appliance that you install in racks that reaches to the readers, and it's calling an API on those from the internals of NetBox. Right now, it's very crude. It's just a Python request, but it could be involved to use developed a bit more to use jobs or like things like WebSockets or things like that to make it quicker. But that was the original goal, was just to do a proof of concept. I think you wanted to present this to a conference, Francois, and that's how it started.
Yeah, we were in a rush to get it out there at Wireless IoT tomorrow in October in Germany, which is the RFID conference. And so we thought that it would be not sufficient to just show the tag themselves, but actually do a full display of what an integration with NetBox would look like. And we kind of missed the mark. We were not able to make the cut with this, but we got it working 2 weeks after the conference. And so the video is not yet on the internet. A few people know about it, so this is our first show and tell to a small audience, and we hope to that you see some very interesting opportunities to start using NetBox to capture RFID tags on cables and actually correlate physical infrastructure with data inside NetBox. And,
yeah, that's the thing. So right now it's limited to locating cables, but we could use this capability to fetch data from the readers and display information from the tag inside of NetBox, like associate, like you mentioned, power usage or temperature data, environmental data, and correlate this inside of an object itself. Like if you were to look at metadata added to a tag, let's say temperature, you could actually see the temperature that the cable is reporting in sort of real time as it's accessed by a NetBox. So so it's all about what you want to do more than what's actually there right now, as it's in infancy. But we could always add functionality based on what's available on the tags themselves.
Awesome. Jonathan, thank you for your time and great effort in putting this together for Francois. Great demo on that side as well. That's that's a novel approach to cable tracing that I've definitely not seen before. So kudos to both of you. All right, absolutely. So let me grab my screen share back. But that hold on. So Maggie, if you could share into chat the link for anybody out there who would like to be a presenter. As you can see, we saw 2 great presentations here today. Anybody out there who would like to present, it doesn't have to be a full-on product or a full-blown plugin. If there's something out there that you're doing neat or novel, or you've come up with a way to just organize your data and you want to show off a little bit, we're always looking for people to come on and present. You never know when your point of view or your industry, your vertical may strike a chord with somebody else. So please, if you do have something, go ahead, click on through that link. Let's see, we should have that in chat now. Yep. Thank you, Maggie. And we'll have you on for a future conversation.
Something that I wanted to call out as well about the topics. A lot of people say, I'd like to present, but it might be too niche or too narrowly focused. That's fine. That's absolutely fine. It's not so much your specific use case that people are always interested in. Even just a novel way of accomplishing something, a way of overcoming a challenge or solving a problem that you were able to tackle might open the doors and like ideas for other people as well. So if you have an idea, throw it out there, and we'll try to get you on a call.
Yeah, I'll take humble brags from people who are just getting into automation and they just want to publicly brag about it. Like, hey, check out this Python script. I finally got it working. There's no such thing as too small of a presentation. Generally, this is why we keep about a 10-minute cap on them. So it's not like you're putting together a 60-minute conversation for a conference presentation or anything like that. So yeah, please, if you have something, come on. We'd love to have you aboard. But that really does wrap it up for us this month. Again, Dave, thank you for setting the alarm. Francois and Jonathan, very impressive tech on your ends. If we, I think what we'll do this month is we'll just go ahead and we'll wrap it up here. We'll wrap up the recording as well. And we'll open up for open conversation afterwards. So thank you everybody who joined us live. If you're watching this back, thank you very much for joining us there as well. Our next, let's see here. I think we have a date. And Maggie, I'll just ask you real quick if we have that next date decided.
I think it's January 23rd. Yeah, we're gonna skip December just because of conflicts with the holidays. So we'll skip next month and we'll see you all in January.
Yep. Thank you, Jeremy. We'll see you all then. Take care.